Hello students, good morning. Today we are taking practice test 2.2. At last lecture we seen root 2 is an irrational number, how to prove by proof. Today we are taking again the same type of sums, but here we will solve by G method. What is the question given? See, show that 4 root 2 is an irrational number. You know that when square root number coming there and inside the square root if no perfect square, then it is irrational. But how to show that? For that we are writing the proof. Here we will take let 4 root 2 is equal to a upon b. Why we taken a upon b? Because a upon b is a rational number. We are using indirect proof. 4 root 2 we want to prove it is irrational, but we will take 4 root 2 is a rational, and for that a upon b we consider, where b not equal to 0, a and b are integers. Then here you will get root 2 is equal to a upon 4b. Multiplied 4 goes to other side and divide. Now when you are observing the sides, what you will get? Root 2 is irrational number, but a upon 4b is rational, because root 2 is irrational in last proof we proved it. Then here left hand side is irrational, but right hand side is rational. Then irrational equal to rational is not possible. And why it is not possible? Because what we assume that our assumption is wrong. What our assumption? Our assumption is 4 root 2 equal to a upon b is rational number. This is wrong. And if 4 root 2 is rational number is wrong, then 4 root 2 is an irrational number, and this is only proved here. Now see, same type of proof for second equation. Here they given prove that 3 plus root 2 is an irrational. Now in last case multiplication form, now here they given addition form. Here also we are writing the same type of proof. We will write let 3 plus root 2 equal to a upon b, where a upon b is a rational number, b not equal to 0, a and b are integers. Here 3 plus root 2, plus opposite is minus, then plus 3 goes to right hand minus, and we will get root 2 equal to a upon b minus 3. Here root 2 is an irrational number, but a upon b minus 3, rational number minus integers, again the answer is rational number, therefore irrational equal to rational is not possible. This also again contradicts our assumption, therefore 3 plus root 2 is a rational number is wrong, means 3 plus root 2 is also an irrational number. Both proofs are same. In last proof multiplication opposite division, and in this proof addition opposite subtraction only we use, and shown there irrational is not possible. See now question 3a. Already this is our last year revision. Represent a number root 5 on number line. Root 5. Now remember, when we are showing on the number line, maximum cases one perpendicular distance we are taking 1 centimeter. Then here you want to show the root 5, means under root the number is 5. 5 is equal to 1 plus what? 4. And 4 is also perfect square or not? 4 is a perfect square of 2. And therefore we will draw a number line and take a point A at 2 units. Then AB we want to draw the perpendicular here number line such that AB is equal to 1 unit. Means here OA is equal to 2 units and AB equal to 1 unit. You get angle OAB is 90. One triangle you make there, triangle OAB. Now it is a right angle triangle, therefore use there Pythagoras theorem. OB square equal to OA square plus AB square. OA distance is 2 square plus AB distance is 1 square. 2 square is 4 plus 1 5, that is OB square is equal to 5. But we want the distance of OB, therefore take square root. Then OB is equal to square root of 5 units. This is the distance we get there. Means like that we can show here irrational number by using Pythagoras theorem. Similarly our second sum they given to show the root 10 on number line. Again I shown here 1 centimeter we are taking the distance, then 10 minus 1 equal to 9. 9 is the square of 3. Then in last case how you taken OA is 2 centimeter. Now you consider here O P is 3 centimeter. OP3, PR 1 we taken. Again use the Pythagoras theorem. OR square equal to OP square plus PR square. Fill the value. Then OR square is equal to 3 square plus 1 square. 9 plus 1 10. Therefore OR is equal to root 10. These numbers you will get. Now here they given, write any 3 rational numbers between the 2 numbers given below. Means they given 2 numbers and in between that which are the coming any 3 rational numbers you want to write. Here they given the first sum is 0.3 and minus 0.5. 0.3 is positive and minus 0.5 negative. Then positive is always greater than negative. Therefore 0.3 greater than minus 0.5, that we know. Now consider here in between numbers 3 numbers we want to find. But when you take here from 3 to 5, then positive to negative we are going. 0.3 we will consider it is 0.30 and minus 0.5 we consider it is minus 0.50. Now 0.30 to negative 0.50, many numbers are there. We will write only any 3 of that. I written there 0.30 is greater than, 0.20 is greater than, minus 0.10 is greater than, minus 0.30 is greater than, minus 0.50. Means which are the number in between positive 30 to negative 50 we consider there, and those any 3 numbers you will write. Not necessary to write only these numbers. You may take any other number in between 0.30 to negative 0.50 there. By same method, next all 3 sums also we solve. Minus 2.3 and minus 2.32. Minus 2.3 we will write it is minus 2.300. And minus 2.33 we will write minus 2.330. Now minus 2 integer part is same, but after decimal point at left here first number 300 and in second number 330. Then 300 to 330 there any 30 numbers you will get, but we want any 3 numbers there. Therefore we written there minus 2.300 is greater than, minus 2.301 is greater than, minus 2.310 is greater than, minus 2.320 is greater than, minus 2.330. Any number from 300 to 330, any number you write, and then these 3 numbers are lies in between given 2 numbers. Third number is 5.2 and 5.3. Again when you observe, you will say that 5.2 and 5.3, no number in between that. But if you add 1 0 there, you can get minimum 10 numbers there. See now 5.2 means 5.20, 20, and 5.3 means 5.30. In between 20 to 30, any 3 numbers you can take. Then I written there 5.20 is less than 5.21, is less than 5.22, is less than 5.23. Like that we can go up to 5.30. Then in between 5.2 and 5.3, 5.21, 5.22, 5.23, you may take 5.27, 5.28.